So this is actually, I always felt silly saying this, but this is one of my favorite topics. And I feel silly saying that because I say that about all sorts of things. Um, but it really is. And I'm just gonna do an example here. And the example I'm gonna work with is 4 over x plus 1 minus 1 over 4 over x plus 1. Oops. 4 over x plus 1 minus 3. And a lot of people freak out when they see these. They it's a super fraction. It really is. All you really need to know is this. Get a common denominator for both. And here I have x plus 1. This is really over 1. So I'm going to multiply this side by x plus 1 over x plus 1. And here I really have it over 1. So I'm going to multiply this by x plus 1 over x plus 1. And when I do that, and then I'm going to combine. I get 4 minus, now remember I have a negative sign here, so the whole thing gets negated. It's going to be minus x minus 1 over x plus 1 over 4 minus, and then I have to distribute, so I get a negative 3x. I get a negative 3 over x plus 1. So now I have a super common denominator, and by that I mean, all I really mean is I have the same denominator in the numerator as I do in the denominator. What I can really do now, and this is super interesting, is I'm going to multiply both sides, or both fractions, by x plus 1 over 1 over x plus 1 over 1. Because remember, this is really 1. And when I do that, this will go away, and this will go away, and now I'm just left with my numerators, which is 4 minus 1 is 3, so I'm going to be left with a negative x plus 3, and I get 4 minus 3 is 1, so I'm going to be left with negative 3x plus 1. That's it. Not all of them are this easy. I'm going to take a look at another one. Hopefully I'll find one that's pretty challenging. Yeah, here's a good one. This one looks pretty hard. Good, nice, good challenge. We have 2 minus 3 over x minus 2 over x squared over 1 minus 5 over x plus 6 over x squared. Now, I always like to make everything into fractions. Now I'm going to take a look. I'm going to say, all right, what's my common denominator here? My common denominator here is going to be x squared. So I'm going to multiply this by x squared over x squared. I'm going to multiply this by x over x. And I'm not going to do anything to that. I'm going to do the same thing over here, x squared over x squared. Oops, should have given myself a little more room. X over x. And when I do that, I'm going to be left with 2x squared minus 3x minus 2 over x squared over x squared minus 5x plus 6 over x squared. I'm going to multiply by x squared over 1 over x squared over 1, and that removes my denominators. You might be able to factor this. So as of right now, my answer is 2x squared minus 3x minus 2 over x squared minus 5x plus 6. One of the things I love about math, and there are so many, is the fact that when you do this, your work should be getting smaller, and that's why I'm not a huge fan of uh, adding and subtracting rational expressions without a common denominator, because the work just ends up becoming more and more difficult, not simpler. Let's see if this works. 2x squared minus 4x plus, yep, that works. And then this becomes x and x, negative 2 and negative 3. And that's negative 5x plus 6. So those will cancel out, and I'm left with 2x plus 1 over x minus 3. And you can see, this is what I started with, the purple, and that's what I ended up with. Things getting simpler, not more convoluted. So I'm going to try to do one last one for you. That was a great example. I rather enjoyed doing that one. This one looks terrifying. Let's see, 2b plus 3. This one looks absolutely brutal. Over, whoa, 6b over 8b squared minus 18. Yowzers. Alright, well this is just going to be, I don't even know where to start with this. Well, that's kind of a lie. If you don't know where to start, just start anywhere. I'm going to multiply this. I need to get a common denominator, so I'm going to multiply this by 2b minus 3, and this by 2b minus 3. Then I'm going to multiply this by 2b plus 3 over 2b plus 3. And when I do that, I'm going to distribute, and I get 10b minus 15 plus 2b plus 3 all over. I'm going to leave it as 2b minus 3 times 2b plus 3. I'm going to factor out a 2 here. Oh, sorry, I have 6b. I'm going to factor out a 2. When I do that, I'm left with b squared. Hold on, what am I going to be left with? Nope, I won't be left with that. I'll be left with 4b squared minus 9. Whoa, are you seeing what's going to happen here? Take a look at this. I'm going to have to move my work down here. So at this point in time, what I'm going to do is I'm going to combine like terms. Alright, so I get a 12b, and then I get a negative 15 and a positive 3, which gives me a negative 12, over 2b minus 3 times 2b plus 3. I'm going to bring that down, and this is going to become a 3b over, and that's the difference of perfect squares, but what is that? It's 2b minus 3 times 2b plus 3. How awesome is that? Because look, my denominators are the same, which means they're going to go away. I can factor out a 12 here, which gives me b minus 1 over 3b. That's going to go away. That's going to be a 4, so I'm left with 4 times b minus 1 all over b. Wow, amazing stuff, amazing stuff. I hope you enjoyed that. This is Peter Omura signing off. You do the math.